convert the given signal flow graph shown in figure to block diagram representation. And thereafter obtain the overall transfer function of the system by block diagram reduction technique. So first we have to convert the given signal flow graph into block diagram. What are the nodes? 1, 2, 3, 4, 5, 6, 7 nodes are there. Now we have to convert this into a block diagram. First let us, between 1 and 2, 2 is junction, it has both the incoming as well as outgoing. In a signal flow graph, outgoing means the outgoing signal consists of all incoming signals, sum of all incoming signals. But in block diagram, we cannot draw like that. In block diagram, we have to take the takeaway point from the output, not from the summing junction. Summing junction is only inlet, not outlet. We cannot take away from summing junction. We can have only one output for a summing junction. We cannot have two outputs for a summing junction. That is the problem with the block diagram representation. That's why this point we have to draw like this. R of S, then summing junction. This is positive, that's why plus sign. This is negative, that's why minus sign. Minus sign H2. Here, the output is taking away as G5. We have to draw like this. Here G1 will be there. This together is called node 2. But while converting block diagram to signal flow graph, don't do like this. Don't combine takeaway and summing junction. Put separate nodes for if you convert this into signal flow graph, you take this 2 and this as 3. But if you combine, no problem. Sometimes it will give problem. That's why we should not do. Not always correct. To avoid that problem, it is better to take separately. Now we have to take away after at 3, node 3, at node 3, there is a takeaway. Takeaway, that is G6. This is after the takeaway at 4, node 4, it is summing. So it is coming here. It is G5 is positive and this is also positive. This is minus sign. That's why this H1 is negative feedback. H1 and G3 between these two, this takeaway and 4, this is node 4. Between node 3 and node 4, there is a block called G2. Then here G3 is there. G3, after G3, one takeaway, that is H1. Then G4. G4. Here, that G6 is coming here. G6 is coming here. This is also plus. This is also plus. Then it is here plus. So one takeaway, already I told you that for summing junction, only one output. From there, we have to take. The 6th node is, these two together is called 6th node. That's all. This is the block diagram from signal flow graph. We have to simplify this. We have to take the innermost part. This is the innermost part. you convert this into, if you reduce this, it becomes G3 divided by negative feedback. That's why 1 plus G3H1. And this is parallel. G1, G5 are parallel, but you cannot simplify that because of this takeaway. That should be taken. We have to move that away. And in addition, this G5 also we can move out of this G1. Then you can combine G2 and G5. So we can draw one more block diagram. That is R of S. Here G1 is there. G1. This is G6. So we moved this G5 from here to here. That's why G5 is doesn't have G1 amplification, but now we have. That's why G5 divided by G1. G5 becomes G5 becomes G5 divided by G1. After that, G2 is there. G2. Here, this G5 is added here. After that, G3 and H1, that is simplified. That's why it can be written as G3 divided by 1 plus G3H1. G6 is coming here. After this, G4 is there. G4, and it is coming here and added here. C of S. H2. Now we can combine these two together. These two together and multiply with this, and we can multiply with this and multiply with this, so that this block diagram is reduced to R of S minus plus G1 is as such, and this is added together. That's why G5 plus G2, G5 divided by G1 plus G2. If you take LCM, then G1, G2 divided by G1. This parallel block is added together, and LCM is taken. Then with that, we can combine this and this. So G3, G4 divided by 1 plus G3H1 C of S. One more block is there, that is G6. G6 is added here. C of S. Now we can multiply these two and we can add G6 because G6 and these are in parallel. This and this are in parallel. That's why we can add them. So what you will get is feedback is there. That is H2 is there. Now we can draw here R of S, G1, G5 plus G2, G1 divided by G1 multiplied by 1 plus G3H1 This and this are multiplied with G3, G4 plus G6. G6 is now added. Here H2 is there. Now we have to remove the H2 now by using 7th rule. What you will get is, now I am writing the numerator. Therefore, the transfer function P of S equal to numerator is G1 multiplied by G5 plus G2 G1 G3 G4 plus G6 multiplied by G1 multiplied by 1 plus G3 H1 divided by G1 1 plus G3 H1. Now we can cancel. Now we can cancel G1 divided by whole divided by 1 plus, here G1 getting cancelled. 1 plus numerator we have to write as G5 plus G2 G1 multiplied by G3 G4 plus G1 G6 multiplied by 1 plus G3 H1 whole divided by 1 plus G3 H1 multiplied by H2 multiplied by H2. So this and this getting cancelled. Therefore, the transfer function P of S equal to numerator, we can multiply with G3, G4. What you will get is G3, G4, G5 plus G1, G2, G3, G4 plus G1, G6 plus G1, G6, G3 and H1. This is numerator divided by the same thing plus H multiplied by H2. That's why we can write 1 plus, if we cancel these two, this must come in place of 1, that is there. Therefore, 1 plus G3 H1 plus, why this 1 becomes G3 H1? Because of LCM, this 1 becomes this denominator plus whatever in the numerator we have to write. G3, G4, G5 plus G1, G2, G3, G4 plus G1, G6 plus G1, G6, G3, H1 whole this multiplied by H2. Overall transfer function is P of S equal to G3, G4, G5, G3, G4, G5 plus G1, G2, G3, G4 plus G1, G6, G1, G6 plus G1, G6, G1, G3, G6, H1. G1, G3, G6, H1, that is numerator. Denominator is 1 plus G3, H1 plus the numerator term multiplied by H2, that is G3, G4, G4, G5, H2 plus G1, G2, G3, G4, H2 plus G1, G6, H2 plus G1, G3, G6, H1, H2. This is the answer from block diagram reduction. Let us check by using Mason's gain formula. For Mason's gain formula, what is the, let us check the answer. T of S equal to 1 by delta sigma Pk delta K. How many forward paths? 3 forward paths are there. Therefore, K equal to 3. So first forward path P1 equal to G1, G2, G3, G4. No part of graph which is not touching the forward path, therefore delta 1 equal to 1. Then P2. P2 equal to G1, G2 we can skip by G5, therefore G5, G3, G4 and delta 2 equal to also 1. No part of graph which is not touching the forward path. For P3, we can travel through G6 bypass. That's G1, G6 and delta 3 equal to the part of graph which is not touching the forward path is this part. Therefore, 1 plus G3 H1, 1 plus G3 H1. That's all about forward pass. Delta we have to find. Delta equal to 1 minus what are the loops? This is the first loop G3 H1, that is minus, therefore minus G3 H1. G3 second loop is G1 G2 G3 G4 H2 minus G1 G2 G3 H2 minus G5. Now we can use G5 G3 G4 H2 minus G1 G6 H2. There are 4 individual loops. Non-touching loops. G6 G1 G6 is not touching G3 H1. G3 H1. Therefore, G1 G6 H2 is not touching. Therefore, plus G1 G6 H2 is not touching G3 H1. That's all about delta. These are all becomes plus because of this minus sign. All becomes plus. That's all about delta. Therefore, the answer is, you can notice that how quickly we are getting for signal flow graph. That's why we can check for correctness. So numerator G1, G2, G3, G4 plus G3, G4, P2, G4, G5 plus G1, G6 multiplied by 1 plus G3, H1 whole divided by delta 1 plus G1, H1 plus G3, H1. Look, this G3, H1. G3, H1 plus G1, G2, G3, H2, G4, H2, G1, G2, G3, G4, H2 plus G3, G4, G5, H2 plus G1, G3, G6, H1, H2. Let us check. One is there. One is there. Here also one is there. G3, H1 is there. Here also G3, H1 is there. G3, G4, G5, H2. This is there. Next term is G1, G2, G3, G4, H2. That is also there. Then G1, G6, H2. G1, G3, G6, H1, H2. That is also there. G1, G6, H2. It's here I wrote, but I forgot to write here. G1, G6, H2. That is also there. In both ways, we got the same answer.